Hello and welcome to Space, here from ESA's Operations Centre in Germany. We're here to talk about ExoMars, a mission which has delivered many twists and turns in the past few days as we followed the course of its mothership TGO and its lander Schiaparelli. We've featured the mission all year in our mini-series Destination Mars, and we'll be hearing the latest from the scientists later in the show. But first, a quick look back at what happened when ExoMars arrived at Mars. March 2016, ExoMars blasts off from Baikonur bound for the Red Planet, its mission to search for methane in the Martian atmosphere. The mothership TGO, the workhorse destined to scan and photograph the planet. Great excitement when it entered orbit perfectly. Not so lucky the lander Schiaparelli. This media star aimed to show Europe could touch down gently onto the Martian dust. Mars had other plans. The first signal was good. Then it dropped away too early. Something wasn't right. Day 2, the situation was clearer. Schiaparelli descended well, then failed close to the surface. Was it the parachute, boosters or software? Analysis will show why this demonstration probe didn't demonstrate how to land on Mars. So Schiaparelli is on the surface of Mars, but it didn't land there like we wanted it to. I'm here with Andrea Racamazzo from the operations team and Stephen Lewis from the science team. Andrea, do we know what happened?
So we don't know exactly what has gone not according to our expectation. There's a large part of the flight that we definitely understand, which is the initial part, the high velocity part, the parachute part. It's only in the final part, when the parachute has been released and the thruster, the retro rockets, were fired. This part we don't understand what has happened yet. We have all the data to understand it, and we are processing them to get a clear picture. Then,
what does it mean for our ability to land on Mars? Because we didn't quite manage it.
Well, it's definitely true that this was a test to test key technologies that we have developed to then do the next mission. We don't understand yet whether it's the technology that is not adequate or the use of the technology information in the logic of the onboard computer that didn't work very well.
Stephen, how do you go away from this as a happy scientist, a disappointed scientist?
It's a very mixed bag of feelings at the moment. We'd have loved to have had that last little bit of surface science, but actually the Amelia experiment is all about understanding the atmosphere as we fly through it, its structure and its density, and eventually all that information will come back to us except for the very last little bit. So we're going to recover nearly all the science we were expecting to get.
Great, thanks very much for your contributions there. Of course, Schiaparelli is only a small part of this ExoMars project. And we had the good news that the Trace Gas Orbiter has entered into orbit around the Red Planet. It's there to look for methane. And here's a little look at why that's so important.
On Earth, methane is linked to life, and given that we've now found methane on Mars, the question can be asked, is there life on Mars?
We know that there are volcanic mechanisms that can produce methane, and it's got very little to do with life in that particular case. You could also, for example, have methane trapped in ices, and again, it's got nothing to do with current life.
The problem with the current detections of methane is that they vary a lot. So some have measured methane more around the equator, others more near the poles. So that's one of the problems with the detection of this gas, which is that we don't know why we've detected it in certain areas at certain periods.
It's going to be very difficult to prove that life is producing short-lived trace gases in the atmosphere.
We've just heard how tricky it is to find those sources of methane on Mars. I'm here with Manish Patel, who works with Anne-Corinne van Dale on the NOBAD instrument on the Trace Gas Orbiter. Are we going for the right thing, looking for methane?
So methane is the headline gas. It's the one that grabs the public attention. If we, for example, if we see a plume of methane, What we have to do is we have to follow it, map it, see where it's going, try and figure out where it came from, and then go back and look at that with, for example, the camera on the spacecraft, take an image of where we think it's coming from. If there are any interesting geological features, there's a possible explanation for the methane we're seeing. By putting all these clues together, by using all of the instruments on the orbiter together, we hope to be able to solve the puzzle, the jigsaw that is the mystery of methane on Mars.
Of course, this spacecraft, which is there now, the TGO, is there to look for methane, but ExoMars is bigger than that, because in 2020, they're going to send a rover down to the surface to dig beneath. Here's a little look at why that is so important.
ExoMars is going to land on one of these regions where there's interesting soil right up to the surface. But at the surface, one can always be affected by the particles from the sun. So for the first time, ExoMars is going to be equipped with a drill capable of taking samples up to 2 meters below the surface, bringing them up and then analyzing them. On Mars, we have terrain that dates from several billion years ago, which we've identified because the presence of water has modified the minerals on the surface. And we've managed to show that there are clays there that were made 4 billion years ago, like witnesses to what happened. And it's not out of the question that in these clays, because there was water and carbon from the sky, that life emerged there in the same way as it probably did on Earth.
I'm here with 2 of the key scientists from the ExoMars 2020 mission, Daniel Rodionov from the Russian side and Jorge Vargo from the European side. Daniel, given what happened with Schiaparelli, should we change how we try to land in 2020?
I think that the landing in 2020 won't depend that much on the 2016 mission, even though the main technologies are going to be the same. But the weight of the lander will be much bigger in 2020. I hope our European colleagues will figure out what went wrong to help us avoid this kind of problem in the future.
Jorge, do we know where we're going to land?
We have 3 candidate landing sites we are considering at the moment. From the 3 sites, 2 are very ancient, large clay provinces. And the last site is an ancient river, a bit like the Nile, with overflowing floodplains.
Given the spots that you're locating, do you think you're going to find life there?
Concerning the signs of life, we've got enough evidence that there might have been life on Mars in the past. I now hope we'll find the real, undeniable proof, and I'm full of hope.
Thanks very much for joining us on the programme. You can follow other news from the universe on our website, Euronews.com. I'll see you next time.